Using Pascal's triangle. Pascal's triangle is a kind of equilateral triangle, where the lateral sides represent the coefficients preceding the highest degree terms and b, n. These coefficients are always 1. This means the lateral sides of the Pascal's triangle contain only 1s. The value in the upper vertex is also 1, as this point represents the intercept of the two lateral lines. In this way, we obtain the following general form of the Pascal's triangle. We have the following shown on screen. The black dots must be replaced with the other coefficients of the binomial according to the following rules. 1. Each row represents the degree of the binomial starting from 0, in the uppermost row. The degree of the binomial increases by 1 each time we get to a lower row. 2. The power of the first variable decreases by 1 when moving from left to right in the same row, while the power of the second variable increases by 1 when moving from left to right in the same row. 3. The sum of two adjacent numbers in a certain row give the coefficient of the term below them. For example, in the second row, we have two 1s. Therefore, the coefficient of the term below them is 1 plus 1 is equal to 2. The Pascal's triangle for binomials up to the 7th degree is shown in the table. This table also shows the expanded form of these binomials in terms of the variables a and b. We have the following shown on screen. Remark: the number of terms in the expanded form of a binomial is 1 more than the degree of the binomial. For example, a plus b to the power of 5 has 6 terms, a plus b to the power of 14 has 15 terms, and so on. Example: expand the following binomials: a 3x plus 2y to the power of 4, b 2 minus 4x to the power of 5. Solution: a, we take a equals 3x and b equals 2y. Thus, since from the Pascal's triangle, we have the following shown on screen. We obtain after substituting the original terms in the expression, we have the following shown on screen. b, again, we can take a equals 2 and b equals minus 4x. Thus, since from the Pascal's triangle, we have the following shown on screen. We obtain after substituting the original terms in the expression, we have the following shown on screen. Since a polynomial is written from the term with the highest degree to that with the lowest one, we can write the expression as the following shown on screen. As you see, the expansions take only a few minutes when made using Pascal's triangle. If the long method discussed at the beginning of this tutorial was used, it would take much more time to expand the binomials. That is all for lesson 12.3.3. To continue this tutorial, please watch 12.3.4. Working with binomial coefficients and the limitation of Pascal's triangle. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.info.